All right, here we go. We're starting chapter 5, lesson 1 on ratios, and what you need to remember is a ratio is a comparison of two quantities using division. It looks like a fraction, but it's division, and it looks like a fraction often, not all the time, and it's comparing two numbers. It's a way to compare. Alright, so this helps us remember, hopefully, that these are the kind of what's happening with ratios. It looks like division, it's a fraction, it's ways to compare things. They show an example with 2 red crayons and 5 green or 5 blue ones, and the ratio is 2 red to 5 green. Okay, now this is not 2 out of 5. What your fraction might tell you, 2/5 of the pizza or something like this. It's very similar to a fraction and actually works the same way in a lot of ways, but when we're talking about ratios, we're comparing two things. And if we have 2 crayons and we have 5 green crayons, then our ratio isn't out of 7, which would be the total number of crayons, but it's 2 red ones. Oops, let's change that color. I was thinking maybe I had done that, and I didn't. 2 red ones over 5 green ones. Okay, so it's 2 to 5. There's 3 ways to write it, which is an interesting fact also. We write it like a fraction often. Okay, 2 red and 5 green. Ratio of 2 red crayons to 5 green crayons. I keep changing it to green from blue, so we might as well stick with that. I know in your book it says blue. We could also write it as in kind of word form. Okay, so we'd write it 2 to 5. And we also can use a colon and write it 2 to 5. And either way, we say a ratio of 2 to 5, a ratio of 2 to 5, or a ratio of 2 to 5. So it's how you'd say the ratio is a ratio of 2 to 5. Okay, let's put the first number that we say on top or in front, and the second number that we say on bottom or last. And then we'll all speak the same language and we'll be able to make sense of it. There's a bunch of pennies and quarters laying on the floor. You count it and you find that there are 5 pennies and 8 quarters. What's the ratio? Well, that's 5 pennies and 8 quarters. The ratio of pennies to quarters is 5 to 8. You also could write it 5 to 8, or you could write it 5 to 8 using a colon. Okay? That's how that works. The ratio of boys to girls. Radar, you're messing up my video again. Stop it. Sit down. Sometimes he just has to bark at everything and you have to go get a glass of milk or something. We're going to talk about the ratio of boys to girls in our class. Good times. We have 9 boys in our class this year. And if you're not in my class this year, or if it's another year, you could change this number. But this year, it's 9 boys to 11 girls. It's almost even. We have a total of 20 people, and you could tell we have 20 people in our class, which is a nice size classroom. But we have 9 boys and 11 girls, which is not a bad ratio. That's what you would say, 9 boys to 11 girls. Or 9 to 11. Or 9 to 11, just like that. Now 9 to 11 and 5 to 8 are both ratios that you can't do anything. You can't simplify them, but say we had a different different ratio of boys to girls in our classroom. Say we had 8 boys to 12 girls. And we could actually simplify this just like we would a regular fraction. This would be the same thing as 4 to 6. And it would also be the same thing as 2 to 3. And we might be able to say, well, in my classroom, there are 2 boys to every 3 girls. Now, the total is 8 to 12, but we a lot of times want to simplify that, and we can skip this middle step. I'll show you how to do that if we start with 8 to 12. And we say, what can I divide both 8 and 12 by? I can divide, we could divide 8 by 2 and 4. And 8, and I can divide 12 by 2 and 3 and 4 and 6. Well, the biggest number that I can see that I can divide both by is 4. So I'm going to kind of draw myself a little arrow and divide by 4 to get 2. And draw the same arrow and divide by the same number. 12 divided by 4 is 3. And I get straight to it. Let me pause real quick. Be right back. Okay, so this is kind of where we go with simplifying and stuff like that. It's pretty easy to do. You can compare them the same way that you would compare a fraction. You could also change it to a percent or a decimal. And so if you had a couple of ratios and you wanted to see which one was bigger or not, let's see what they did. They started with a nice comparing ratios. They had, you got 24 out of 30 questions correct on a quiz, so you got 24 right over 30 total. Okay, so this is another way to do a ratio. This isn't 24 right out of a certain number wrong. This is a 24 right out of a certain number total. So this is a little more like an actual fraction and still works as a ratio. I like to see this. You see this all the time. Scores on your quizzes and tests and stuff. 24 out of 30 questions. Your friend got 35 out of 40 on a different quiz. So that's why they have different numbers. 35 right out of 40. And you want to see who did better. And you could just find a percentage, which you guys worked on in the last chapter, and that would be a smart way to do it. We start by, you might not have to do this, but it just sometimes makes sense, simplifying the ratio first. So what can you divide both 24 and 30 by? You can divide this one by 6, and you can divide this one by 6. So we're going to divide them both by 6 and see if we get what we think is the simplest. 4/5. So I got 4 out of 5 questions right. That's the simplified version of getting 24 out of 30 right. Okay, how did my friend do? We can divide that one by 7, but that doesn't work for 40. We can divide it by 5, and that works for 40. So we're going to divide it by 5. Divide both of them by 5. And this is 7 out of 8. 40 divided by 5 is 8. 35 divided by 5 is 7. So 7 out of 8 questions right now. Right away I know that my friend did a better job than me because he only missed 1 out of more questions than I missed 1 out of. I only missed 1 here, 4 out of 5. He missed 7 out of 8. So that means that he only got 1 wrong. I only got 1 wrong too, but there were fewer questions, so I didn't do as well. But it still makes sense to try to figure out an actual percentage, and you can use a calculator and just divide 4 by 5, or you can remember some of the things that we did last chapter and change 4/5 to 8/10, which is the same as 0.8, which is the same as 80%. So I got an 80% on my test. That makes sense. Well, how did my friend do? Well, 7 out of 8 is actually the time for long division or a calculator. So we have to do this method on the video. And it's just sort of, it's tedious, takes a little bit of time. 8 times 8 is 64. That leaves 60. 8 times 7 is 56, which leaves 44. Actually just 4, and then I break down the 0, makes 40. And then that goes 5 times. So my friend actually got a 0.875, which is equal to an 87.5%. So I got an 80, my friend got an 87.5%, so the better score is definitely this one over here. Yeah, you could tell. And you might have known already, but this is how you do all the work. This is how you basically do everything you need for this lesson. You got to use what you learned last chapter. That doesn't go away, and that's one of the cool things about math is it doesn't go away. You have to keep bringing it back, so learn it. And you have to learn what you also learned, use long division, use your decimals, change things around, but now we're doing it with ratios. Okay, that's pretty much going to, I think, get you through everything you need to know. There's some nice, easy ones, and a little geometry and stuff to go along with it. But you guys enjoy this lesson, and I'll help you in school. All right, bye.